Let us revisit theoretical probability that we have studied in earlier classes. Theoretical probability allows us to predict what happens in an event without actually performing an experiment. The theoretical probability of an event E expressed as P function E is defined as P function E is equal to number of outcomes favorable to E divided by the number of all possible outcomes of the experiment of PE, that is equal to M over N for M greater than 0 and greater than N, where M is a favorable events and N is the total events associated with the random experiment. Let us solve a spinning problem. A spinner has 5 sectors: color yellow, blue, green, and orange. What are the chances of the spinner stopping at A. Orange, B. Green? We know probability of an event PE is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Here, the number of all possible outcomes of the experiment is equal to 5. Number of outcomes favorable to spinner stopping at orange is equal to 2. Number of outcomes favorable to spinner stopping at green is equal to 1. Substituting the values and simplifying, we get probability of spinner landing at orange, P orange, is equal to 2 over 5, and the probability of spinner landing at green, P green, is equal to 1 over 5.
Ooh!
Here is a fruity problem to determine the probability of picking a fruit from a basket. A fruit basket contains 5 oranges, 5 apples, and 10 bananas. YB picks up a fruit randomly from the basket without looking at it. What is the probability of him picking A. An apple, B. An orange, C. A banana? Probability of an event PE is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Here, the number of all possible outcomes of the experiment is equal to 20. Substituting the known values and simplifying, we get probability of picking up an apple, P apple, is equal to 5 by 20, that is equal to 1 by 4. Probability of picking an orange is 5 by 20, which is equal to 1 by 4 again, and the probability of picking a banana is equal to 10 by 20, that is equal to half. Therefore, probability of picking an apple is 1 by 4, probability of picking up an orange is 1 by 4, and the probability of picking up a banana is 1 by 2. 2 coins are tossed simultaneously. Find the probability of getting A. 2 heads, B. 1 head, C. At least 1 head, D. Not more than 1 head, and E. No head. We know that probability of an event PE is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. On tossing the 2 coins, the outcomes possible are HH, TT, HT, TH. So, the number of all possible outcomes of the experiment is equal to 4. And the number of favorable events for getting 2 heads is equal to 1. Therefore, probability of getting 2 head, P 2 head, is equal to 1 by 4. The number of favorable events for getting 1 head, that is equal to HT, TH, is equal to 2. Therefore, probability of getting 1 head, P, 1 head, is equal to 2 by 4, which is equal to half. The number of favorable events for getting at least 1 head, that is HT, TH, HH, is equal to 3. Therefore, probability of getting at least 1 head is equal to P, 1 head, that is equal to 3 by 4. The number of favorable events for getting at most 1 head, that is HT, TH, TT, is equal to 3. Therefore, probability of getting at most 1 head is equal to P at most 1 head, that is equal to 3 by 4. Number of favorable events for getting no head, that is TT, is equal to 1. Therefore, probability of getting no head is equal to P no head, that is equal to 1 by 4. Tom rolls a dice. In a single throw, what are the favorable outcomes for getting A, number 1, on the dice, B, a number greater than 2? To solve this, let us recall that the set of all possible outcomes of rolling a single dice is 6. 1, 2, 3, 4, 5 and 6. Here, S represents sample space, which is defined as the set of all possible outcomes of rolling a dice. There is only one favorable event of getting 1 on the dice. Such an event is called elementary event. Similarly, for numbers greater than 2, the outcomes are 3, 4, 5, 6. So, the number of outcomes favorable to E is 4. The event can be further subdivided or broken down into 4 simpler events, namely the event of getting 3, getting a 4, getting a 5 and getting a 6. The event associated with this experiment is a compound event. What do you conclude from this? From this example, we can conclude that an event associated with a random experiment is an elementary event if it has only a single outcome, and an event associated with a random experiment is a compound event if it has 2 or more outcomes. Now, find probability when a dice is rolled and a coin is tossed together. A dice is rolled and a coin is tossed. Find the probability that the dice shows an odd number and the coin shows a head. Here, the sample space S of the experiment is S, that is equal to 1, H, 2, H, 3, H, 4, H, 5, H, 6, H, 1, T, 2, T, 3, T, 4, T, 5, T, 6, T. Let E be the event. The die shows an odd number and the coin shows a head. The combinations would be 1, H, 3, H, 5, H. We know that probability P of E is the ratio of the number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Substituting the known values and simplifying, we get probability P of E is equal to 3 by 12, that is equal to 1 by 4. 2 dice are rolled. Find the probability that the sum of the scores of the die shows A, a sum equal to 5 and B, sum less than 5. If 2 dice are rolled, the sample space S is given by S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. We know that the probability P of E is the ratio of the number of outcomes favorable to an event to the number of all possible outcomes of the experiment. The number of favorable events of getting a sum of score 5 is 1, 4, 2, 3, 4, 1, 1, 4, that is equal to 4. So, the probability of the event P, sum of 5, is equal to 4 by 36, that is equal to 1 by 9. The number of favorable events of getting a sum less than 5 is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 3, 1, that is equal to 6. Similarly, the probability of the event P, sum less than 5, is equal to 6 by 36, which is equal to 1 by 6. Probability of getting sum equal to 5 is 1 by 9, and the probability of the event of getting sum less than 5 is 1 by 6. There are 5 cards with alphabets A, B, C, D, E printed on them. What is the probability of drawing a card with the letter A from the bag without looking at it? Now, let us determine the probability of a certain of sure event. Here, the number of outcomes favorable to the event E is equal to 1 and the number of all possible outcomes of the experiment is equal to 5. Recall, probability P of E is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Therefore, probability of the event PE is equal to 1 by 5. What do you think is the probability of not getting a card with the alphabet A? Let us denote the event not E by E bar. Therefore, the probability of not getting the event is represented by PE bar, and the event of getting a letter not A has favorable outcomes of the event represented by the sample space S is equal to B, C, D, E. Therefore, the sum of all the possible outcomes of the experiment is equal to 4. Substituting these values, we get probability of the event P not E is equal to PE bar, that is equal to 4 by 5. What would be the result of adding up the probabilities of both the events? Here, PE plus PE bar is equal to 1 by 5 plus 4 by 5, that is equal to 5 by 5, which is equal to 1. So, PE plus P not E is equal to 1. PE plus PE bar is equal to 1, or PE bar is equal to 1 minus PE. The event E representing not E is called the complement of the event E. We also say that E and bar are complementary events. What can you conclude from this expression? The complement of an event A is the set of all outcomes in the sample space that are not included in the outcomes of event A. Complementary events, when combined, make the entire sample space, so their probabilities have a sum of 1. 10 magnets with the first 10 alphabets in English are stuck on the refrigerator. A child takes off some magnets from the refrigerator. What are the chances of the child taking off a magnet with A. Vowels, B. Consonants? Oh, the child has picked up a vowel. The sample space for the problem is A, B, C, D, E, F, G, H, I, J. The total number of possible outcomes is 10, and the number of the favorable outcomes of picking vowels is A, E, I, that is equal to 3. We know that the probability of picking up a vowel, P vowel, is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Substituting the values and simplifying, we get probability of picking up a vowel, P vowel, is equal to 3 by 10. Now, the child has picked up a consonant. The number of favorable outcomes of picking consonants B, C, D, F, G, H, J is equal to 7. So, probability of picking up a consonant, P consonant, is the ratio of the number of outcomes favorable to an event to the number of all possible outcomes of the experiment, which is equal to 7 by 10. Is there an alternate method of finding the probability of picking up the consonant? Probability of picking consonant is the probability of not picking a vowel. Here, the probability of picking up a vowel is equal to p vowel, that is equal to 3 by 10. Therefore, the probability of picking a consonant is equal to 1 minus p vowel. Substituting the value and simplifying, we get probability of picking a consonant is equal to 7 by 10. Two players, Rohan and Ravi, play a tennis match. It is known that the probability of Rohan winning the match is 0.53. What is the probability of Ravi winning the match? The probability of Rohan winning the match is P Rohan, that is equal to 0.53. So, the probability of Ravi winning the match, P Ravi, means a probability of Rohan not winning the match. That is, the two events are complementary. Therefore, probability of Ravi winning the match P Ravi is equal to 1 minus P Rohan. Substituting the known values and simplifying, we get P Ravi is equal to 0.47. Therefore, the probability of Ravi winning the match is 0.47. YB is shuffling the cards. He draws cards at random from a deck of cards. Find the probability of getting A. 4 of spade, B. a queen, C. a king of club, D. neither an ace or a king. The probability of event is given by PE, which is the ratio of number of outcomes favorable to an event and the number of all possible outcomes of the experiment. YB shuffles the cards and draws one card, which is a spade of number 4. Observe that the sample space shows that there is 1 4 of spade. Hence, the probability of event E occurring is given by PE, that is equal to 1 by 52. YB shuffles the cards and draws 4 queen cards. The sample space shows that there are 4 queens. Hence, the probability of event E occurring is given by PE, that is equal to 4 by 52, which is equal to 1 by 13. YB shuffles the cards and draws a card representing the king of club. The sample space shows that there is 1 king of club. Hence, the probability of event E occurring is given by PE, that is equal to 1 by 52. There are 4 kings and 4 aces. Hence, the number of favorable outcomes for getting a card which is not a king or an ace is 52 minus 4 plus 4, that is equal to 44. Hence, the probability of drawing a card which is neither a king or an ace is equal to 44 by 52, that is equal to 11 by 13. Therefore, the probability of drawing 4 of spade is equal to 1 by 52. Probability of drawing 4 queens is equal to 1 by 13. Probability of drawing king of club is equal to 1 by 52. And the probability of drawing a card which is neither a king or an ace is equal to 11 by 13. Now, find the probability of picking up a defective bulb. YB just brought a box of 20 colored bulbs to decorate the Christmas tree. The shopkeeper has cheated him by placing 4 defective bulbs in the lot. YB takes out one bulb at random from the box. What is the probability that it is a non-defective bulb? Total number of outcomes is equal to 20. Number of favorable outcomes is the number of picking up non-defective bulbs, that is equal to 20 minus 4, which is equal to 16. Probability of picking up a non-defective bulb is equal to P non-defective bulb, that is equal to number of favorable outcomes divided by the total number of outcomes. Probability of picking a non-defective bulb the first time is equal to 16 by 20, that is equal to 4 by 5. Suppose YB does not put this bulb back in the box and takes out another bulb from the box. What is the probability that the second bulb is not defective? When YB draws the second bulb, the total number of possible outcomes becomes 20 minus 1, that is equal to 19, and the number of favorable outcomes of picking up non-defective bulbs is equal to 19 minus 4, which is 15. Therefore, the probability of drawing a non-defective bulb the second time is equal to 15 over 19. Therefore, the probability of picking up a non-defective bulb the first time is equal to 4 by 5, and the probability of drawing a non-defective bulb the second time is equal to 15 by 19. YB throws a dart at random onto a board. Calculate the probability that the dart will hit the shaded region. Radius of the total board is equal to 10 centimeters, and the radius of the shaded portion of the board is 5 centimeters. Area of a circle is given by pi r square. Here, the total area of the dart board with radius 10 centimeters is equal to 314.2 centimeters square. The area of non-shaded circle of radius 5 centimeter is equal to 78.5 centimeters square. Therefore, the area of shaded region is equal to the difference of the areas of the total area and the area of the shaded region, which is equal to 235.7 centimeters square. Therefore, the probability of hitting the shaded region is the ratio of area of shaded region of the board and the total area of the board. Substituting the value and simplifying, we get probability of hitting the shaded region is equal to 0.75.